Good morning, guys. I was uploading all the worksheets, so sorry it took me a minute. Is there a particular place that is it, Sophia, is there a particular question that you wanted to address this morning?
I don't get any of the charts, like the one that you have pulled up right now, and then the one where we have all the blanks that you're trying to explain to me in class.
Okay. All right. Hold on one second. I thought my stylus was here, but it wasn't. All right. Do you care if we start with this one and then we'll move to the other one?
Yeah.
Okay. All right. Let's see. I think I have, yeah, I've got the sheets too attached. Okay, let's take a look at number one. Number one, we can see that it's crossing the y-axis. I'm going to see if I can blow it up. Did that become bigger for you guys as well?
A little bit.
Okay. All right. We can see that it's crossing the y-axis right here. Actually, let me erase that because I want to. I'm going to change my color so it shows up a little bit better. The y-axis right there. Okay. And that's at point 0, because the x is going to be 0 and the y is 2. So the y-intercept is 0, 2. The x-intercept
is 6, 0.
Yes. So that's where the intercept means intersection, where it's crossing, all of those things. That's what that means. Graphically, that's what that means. Algebraically, when you plug it into an equation, if you were just to plug that in, you would plug a 0 in for the x and a 2 in for the y. If you're solving for an intercept, okay? So like, let's say you didn't know what it. I'll get to that in just a minute. So hopefully that'll explain something. Oops. I don't know. Hold on. Why is my computer singing to me? Sounds beautiful. I think I stopped it. Okay, my computer was singing to me, so that set off my ADD, like it was going all over the place. Sorry about that. All right, so now for the slope, to figure out a slope of a graph, it's rise over run, okay? So just working on that, that means if I'm going to measure, the rise is this part here. So that is 2, right? If I'm going from there to there. You don't necessarily have to move directly from the y-intercept to the x-intercept. You could actually go right here if you wanted to. Just because that's the next place on the graph where it's actually getting to a point, like you see like an intersection. Does that make sense? Of a coordinate. It's the intersection of, you could actually do that one if you wanted to. Either the slope is the change in y over the change in x. So that's literally the movement from one point to another point. And technically, if you were to measure it anywhere on the graph, it should still come up to be the same difference, no matter where it is. We just obviously like to use whole integers if possible, because that's the most user friendly, you know, because when you get into the other places and they're not whole integers, it doesn't make it, you know, it's more difficult. But let's just say we're counting and we wanted to use that original y-intercept and x-intercept. The slope is 2 over 4, which then reduces to 1 over 2. So it's the change in y over the change in x. And what we learned later is to take the coordinates of the point, like the x and y ordinates, if you will, of the coordinates, and actually manipulate them in a formula in order to find it if you didn't have a graph. But
Where'd you get the board?
Isn't it 2 over 6 or negative 2 over 6?
Oh, I'm sorry. It did. And I messed up. It is 6. And my apologies. It helps if Miss Sparks writes the same right number. And Miss Sparks can't always count. So it's a good thing that you're watching me, Eli. Anyway, from here, we went down 2 and then over 6. So that goes to 1/3. But had I done it from, that's that one. Had I done it from here to here, which is the next closest point on a certain cross section, that would have been, I would have gone down 1 and over 3. Does that help a little bit, even though I messed up the numbers the first time? So now I actually can write the slope-intercept form because I have the slope and I have the y-intercept. With the slope-intercept form way down here, the slope-intercept form, it's actually referencing the y-intercept. I know that there's oftentimes 2 in an equation, but the slope-intercept is referring to the y or the b-intercept. Okay? That's that b. Y equals mx plus b. The m is the slope. So m equals this. And then the y-intercept is positive 2. All right, let's move on to 2, because I think the more we practice this, it'll be better. And maybe Miss Sparks will count better this time, Sophia. All right, so the y-intercept here is what?
Negative 2.
Yes. So it's the point itself is 0, negative 2. The x-intercept is 4, 0. And now we'll count. There is another point right here, which is actually 2, negative 1. If I counted rise over run, I would get 1/2. And actually, I went up 1 and right 2. So that is a positive because I went in 2 positive directions. So I have my slope. So I can write this in slope-intercept form. Slope-intercept form is y equals mx plus b. So my slope is the m. And the intercept is the y-intercept. So number 1 is k, and number 2 is I. Number 3 we can see that it's crossing the y-axis at 1, 2, 3, 4, 5, 6. So it's 0, negative 6. And I'm looking for a good solid point that I can count where there's a good cross section. That's going to be right there. Any one of these will work, actually. And the rise is up 1, and the run is over 1. And it happens again. Up 1, over 1. Up 1, over 1. So it's going all the way. So we've got m equals 1 over 1, or 1. So now I can write my slope-intercept form because I have my slope and I have my y-intercept. So I'm going to plug in my slope. I can write 1x if I want to, but I don't have to because remember, the coefficient of 1 is understood. So I wouldn't necessarily have to write that, and it's probably not going to be in the answer bank that way. It's probably going to be x equals negative 6, which it is. D. But it's not quite crossing the x-axis, is it? So what I'm going to have to do is plug in 0 for y to find my x-intercept. Does that make sense to you? Because what is, if you look at numbers 1 and 2, what is the y coordinate for the x-intercept? Eli, can you tell me?
What was the question again?
What is the y coordinate for the x-intercept on numbers 1 and 2? What would the y be for the x-intercept? When you look at that ordered pair for the x-intercept on number 1 and 2, what is the y?
2 and negative 2.
No, what's the, I'm sorry, on the x-intercept. Let me, on the x-intercept, what is the y coordinate on these? What's the value?
0.
Yes, sir. Good job. So that's why you substitute a 0 in for the y when you're finding the x-intercept. If I plug in a 0 for the y and I solve for x, I will get the x-intercept. So the x-intercept is 6, 0. So graphically, it's where it crosses the x-axis for the x-intercept, but algebraically, it's where you have a 0 in for the y. Graphically, the y-intercept is where it crosses the y-axis, but algebraically, it's where you would actually put a 0 in for the x and solve for y. Is that making any more sense?
Yeah, I get it.
Sophia, are you getting it better now?
Yes.
Oh, praise the Lord. Okay, let's keep working. How about you, Eli? Is it becoming a little clearer? You want me to work through a few more?
Can you work through a few more, please?
Yes, sir. I certainly can. I'm happy to. Thank you for asking and for your honesty. All right. So on number 4, it's the line is crossing the y-axis at the point of 2 on the y-axis, but I know my x is 0 because every single place on the coordinate plane can be identified with an x and a y. It's like 2 locations. Remember, we kind of talked about it as north and south and east and west. And the y is the north and south, and the x is the east and west. So, when you're traveling, oftentimes you're traveling in 2 directions, like northwest or southeast or whatever. For the coordinate plane, you're traveling in 2 directions. So you have, it's kind of like latitude and longitude on a map. So you have a 0 and a 2 for the y-intercept. For the x-intercept, I know that the y is going to be 0 and and the x is going to be the value of the point where it's crossing the x. 1, 2, 3, 4. So I have my x-intercept and my y-intercept. And now I want to look at some other points to calculate my rise over run. So, or change in y over change in x. So it looks like we're going down 1 and right 2. Down 1 and right 2. And you can see that it's still doing it all the way across. Down 1, right 2. But if I were to go this direction, up 1, notice that I'm going left 2. So I traveled in one direction positive and one direction negative. Up 1, left 2. So it's always the change in y over the change in x. So, and when the slope is negative, as it is here, you will be traveling either rising, and obviously we say rise, and maybe that part is a little confusing when we say rise over run, because you're thinking, oh, I'm always going to be rising. Well, obviously, when you go down, you're not rising, but it's just the direction, whether you're going up or down, and up is positive, down is negative, over your left and right direction. And left is negative and right is positive, just like a number line, because both the x-axis and the y-axis are really number lines. They're just great big number lines that travel in all the way to negative infinity to the left for the x-axis and positive infinity to the right on the x-axis, and vice versa for the y. It's positive infinity for when you go up and negative infinity when you go down. Now on number 4, I have y equals, and then my slope, negative 1/2 x, and then my y-intercept, the value of the y-coordinate of the y-intercept, and that's a positive 2. That's A.
Can you do number 11?
Yes. Number 11. It's crossing the y-axis at 1, 2, 3, 4, 5. So it's going to be 0, -5. And then we want to look for the next point that's closest to that, because I always try to do the closest, because that way you don't have to reduce the fraction. I mean, obviously any point will work to find the slope, because it's always the change in y over the change in x. But the next closest will give you the smallest fraction, which is, unless y'all want to be reducing fractions, that's the easiest. I know how much y'all love fractions. So it looks like we're going up 1. And how many over are we going? 1, 2, 3. So m equals, and we went up 1, and we went right 3. Okay, so there's our slope. And let's just confirm, up 1, right 3. So that's our slope. And then, so now what we want to do is go ahead. We can't really see where it's going to go through the x-axis here. Can't even really guess. Like way back on number 3, you could kind of guess, but on this one, we really can't guess. So we need to take our information that we have. We have the slope, and we can plug that into the slope-intercept form. We have our intercept, which is -5. So we have enough information to put it into a formula. So now what I want to do to find the x-intercept is I want to plug in, remember, when we have an x-intercept, our y value is always 0. So we'll take this equation and we're going to plug in 0 for y and solve for x. And that will be our x-intercept. Probably didn't give myself enough room. I'm going to add 5 to both sides. And that gives me 5 equals 1/3 x. And to clear a fraction, you multiply it by its reciprocal. So I'm going to multiply this side by 3/1 and this side by 3/1. So that gives me 15 equals x. So if you can read that, that's 15, 0 for my x-intercept. And it would be my suggestion, based on as I'm watching you guys, to always write your x and y intercepts now in ordered pairs. because I feel like y'all are, it's getting a little confusing for you guys, thinking that it's just like when you write down the y-intercept as just -5, you're not seeing that the y-intercept is actually an ordered pair where the x is 0. And the x-intercept is an ordered pair on the coordinate plane, but the y is 0. All of these points on the coordinate plane are ordered pairs. There's an x and there's a y. Even when it's crossing the y-axis and the x-axis, it is still an ordered pair. It's just the value of one of the ordered pairs is going to be 0 with respect to the fact of whichever axis it's crossing. The other one would be 0. Okay, so I've done 5 on this worksheet. I think I'm going to do number 5 also to give you an example of the horizontal line. The slope of a horizontal line is always, Brooke, will you come get Guess? She's tangled up in, you'll have to actually get her, because she's tangled in the cord. Where do you want me to put her? If she won't go lay on her bed, we're going to have to put her outside. I'm sorry, guys. The slope of a horizontal line is always 0. Okay? So we don't really have to measure anything for this. But you can see there's absolutely no rise over run. So it's just 0 for this. I mean, you can do it algebraically and prove that the top will end up 0. But that's why a vertical line is undefined, because the x would be 0. That's not allowed. The y-intercept, it crosses the y-axis here. And that's 1, 2, 3. Has 0, 3. It never crosses the x-axis, so there is none for this. And the equation of a horizontal line is always y equals something. And it's always going to be whatever the y-intercept is. So in this case, it's y equals 3. All horizontal lines have an equation that begins with y. So I don't know if you want to write that down in your notes somewhere, if you want to put a post-it note over this particular graph to remind yourself of that, and then maybe make a note in your notebook. But the concept maps, which I'm going to move on to those in just a minute, it is, I'm thinking that we're going to cut all of those and put them in our notebook. So it'd be another, and we have a horizontal line on it as well. So that'd be a good place to put it too. But that's the case for this. Is there any more on this worksheet that you guys would like me to do?
Can you do 10, please?
10. Yes, I sure can. The y-intercept. And if you guys will notice, pretty typically, I'm always going after that y-intercept first, because that's the one that's in the slope-intercept form. So that's the one I quickly go to, because I can then get it into some type of formula so that I can solve for any other points on the line, if at all possible. So that's the one that I'm jumping to first. 1, 2, 3, 4, 5, 6. So the y-intercept is 0 for the x and -6, because it crosses the y-axis at the point of -6. The x-intercept, 1, 2, 3, is 3, 0. My slope, let's see, this looks like a good solid point, and this looks like a good solid point where it's crossing on the grid lines. So I can calculate it by counting up 1, 2, and right 1. Just to confirm, up 2, right 1. Up 2, right 1. And if you could tell, this is going to go left 1, down 2. So that's traveling in 2 negative directions, which would also give me a positive slope. So the slope is the change in y over the change in x, and this particular one reduces to 2 because it was originally 2 over 1. So I have enough information, and I had it even, I don't need to write the mx plus b format. I don't have to write the x-intercept. It's just nice to have it because it gives you another good solid point on the line. But y equals, what's the slope on this one? Anybody? 2. So 2x, because it's mx, so 2 is the slope, 2 for mx, and then minus 6, because that's the value of the y-coordinate in the y-intercept, or actually the y-intercept. Is this making more sense to you guys as far as how the line and the equation of the line connect, and how you can see things in the equation that would help you either take it from the graph to the equation, and we actually should be able to take it from the equation to the graph as well.
Yes.
Okay, good. I'm going to move to the concept map. Unless there's any more questions on this one. Any more? That leaves a good 1, 2, 3, 4, 5 for you guys to do. And I don't care if you guys are helping each other out or anything like that, but that gives you 5 problems to kind of work on your own, just to make sure that you're really getting them. You can ask me about them in class or ask your classmates. I'm happy for you guys to help each other this week, because the more you guys help each other, it means that you know it. If you can teach it, you know it. I'm just going to go back over this one. Can anybody tell me from the equation, what is the slope of y equals 3x plus 2? What's the slope there?
3.
Good job. 3. All right. So because slope is rise over run, I might want to make myself a little note right here that says 3 over 1, because I know it's a proportion. It's going to be rise over run. I'm going to be traveling either up or down by the count of 3, and I'm going to be traveling either left or right on the coordinate plane by the count of 1. Okay, the y-intercept. What is the y-intercept here?
0, 2.
0, 2. Good job. So to graph that, I don't go left or right. 0 and then 2. So that goes right there. So now I'm going to use my slope to create some additional points. So I would travel, it's a positive slope. So I'm going to go up 3, 1, 2, 3, and right 1. I can also travel in 2 negative directions because a negative divided by a negative is still a positive. So I'm going to go down 1, 2, 3, and left 1. 1, 2, 3, left 1. So what are the coordinates? Eli, can you tell me the coordinates for this point way up here?
Which one?
The one at the very top of the graph, way up here. That's great.
1 and
I'm putting
5.
a green check mark, right? 1, 5? Yes, sir. Good job. What are the coordinates of this point right here?
Negative
Green
1
check
and
mark.
negative 1.
Yes, sir. Good job. We've now become an overachiever in our 2 points on the graph. Okay, and if I connect these, and Miss Sparks' line is not going to be very pretty. I'm sorry. But if I connect those, I can see that it's not going through the x-axis at a very precise point. So I can take my equation, and what am I going to substitute in for y to get the x-intercept?
2.
To get the x-intercept. What will I substitute in for y to get the x-intercept? 0. Because the y coordinate for the x-intercept is always 0. And now I would solve for x. Divide both sides by 3. And I have negative 2/3 equals x. So the x-intercept is negative 2/3. And the y is going to be, and if you'll look at it right there, I just put a green dot there. If you'll look at it, that's probably about right too. It looks like it's actually going through the x-axis right about negative 2/3 or negative 2/3. That's about where it's hitting it. Did everybody get my work here so I could erase it right here? Did everybody get this?
Yes. Yes.
Okay.
Yes, ma'am.
All right. Are we starting to see if you don't have the x-intercept? Okay, if I don't have a y-intercept, but I have an equation, how do I find the y-intercept with just an equation?
Substitute the x for 0.
Yes. That's what you would do. That's perfect. And if I don't have the x-intercept, what would I do?
Substitute the y for 0.
Perfect. Awesome. And what we learned later, and that's really when it's in standard form, because What we later learned is that we can actually just look at that. But I'm glad that you all remember how you can do it algebraically. I appreciate how you answered that, Sophia. That was perfect. Now we want to move this into standard form because that's what it's asking for down here. Okay? So we start with y equals 3x plus 2. And to get it in standard form, you have to subtract 3x from both sides. Wish I had a little more room. Now I have negative 3x plus y equals 2. And that's awesome, but remember, mathematicians don't like to lead with a fraction or a negative number. So what could I do to get rid of the negative off the front of that negative 3?
Divide by -1.
Good job. Divide by -1 or multiply by -1, divide by -1, any way you want to think about it, because that's going to change the sign on every single term in this equation. So I would go from, if I did that, I would now have a positive 3x, which was my goal. But what's going to happen to my y term?
It's going to be negative.
That's right, negative y. And now what's going to happen to that 2?
It's also going to be negative.
Yes. So it's 3x. So my final answer, can I erase all of that or are y'all still writing?
I got it.
Okay.
I got it.
Okay. Because I just want to make sure that I put it in the right way. And then that way, when y'all look at this, you'll be like, oh, okay. So your final answer should look like this. Okay.
Okay.
So this, on the other worksheet, you are taking a line that's already on a graph and you're getting all of this information. And on this particular worksheet, on these concepts, you're given an equation and then you're transferring it to a graph. To make sure, I'm trying to make sure that you all connect that these two variable equations, because the coordinate plane is made up of both a horizontal number line and a vertical number line. The horizontal number line is the x-axis and the vertical number line is the y-axis. And so that's why an equation with two variables is always going to graph as something. Next semester, we'll learn about when we square the x and we square the y, we get a different shape. So as we adjust through all of these different things, it changed the shape on the graph. But all of these concepts kind of stay the same as far as when you have an ordered pair, it's always going to designate a very specific place on that coordinate plane. Okay. I'm going to move down to this equation right here, which I think for you, oops. Oh, please tell me it didn't go away. Thank you, Lord Jesus. I think this is page 2 for you guys. Is that correct? What page is this? Where you have the net y equals negative 1/3 x. I'm sorry?
2.
Okay, thank you. All right. I'm going to jump to this one because I want to show y'all something cool. Well, I think it's cool. All right. Can anybody tell me what the y-intercept is for this equation?
Negative one.
Yes,
Oh, wait.
0, -1. All right. What is the slope for this one?
-1/3.
-1/3. So that means I've got to travel in one negative direction and one positive direction, because a negative divided by a positive. So if I go down 1, I want to go right 3, because down is negative, right is positive. Okay, so down 1, 1, 2, 3. And if I go up 1, I want to go left 3. So up 1, 1, 2, 3. So I've got a couple points on the graph by graphing it now. What are the coordinates for this point there? Can anybody tell me with the check mark by it? What's the point for that? 3, -2. Good job. And then this point up here.
0, -3. I mean -3.
Yeah, -3, 0. Good job. What's special about that point?
The y 0.
The y is 0, which makes it the what?
X-intercept.
The x-intercept. So praise the Lord. We used the slope to solve it, and it was there and everything. We didn't have to do anything. Yay, right? Okay. Now, remind me, okay, what's this? This is a -1/3, right? Okay. So what is the slope? Where did it? Oh, it went away. Didn't I work that all? Didn't I have this all like worked? Oh, praise the Lord. I was like, y'all, didn't I work that out? Okay, what is the slope for this line?
3.
3. Good job. Can anybody tell me what is special about this line and this line? Just given the slopes.
They have the same slope.
Not quite the same, but you're noticing a connection, and I'm really proud of you for that. Not quite the same. The other slope, let me just write it here so that it'll be a little clearer to see. What is it? Not quite the same.
Perpendicular?
It is perpendicular. It is indeed, because Ellis did a very good illustration on the board yesterday that showed us their opposite reciprocals of each other. This technically is 3/1, and this is -1/3. So this line is actually perpendicular to the other line. So if I graphed them on the same graph, they would form a right angle at the point where they intersect.
Oh.
Very good. Are y'all making a few connections?
Yes, ma'am.
Praise the Lord. Praise the Lord. Praise the Lord. The other one was what? What was it? Y equals 3x. Was it +2?
Yes.
You're going to go on and we don't.
I'm sorry?
How did you get -3 and 0 on the x-intercept?
How did I get that? Great question. Where is it crossing the x-axis? This is the x-axis, the horizontal line. Where is it crossing? Oops, I covered the little number now. Do you see that?
-1 and -3.
Where, right here. What is this right here? This is y. Yeah. Well, yeah. -1 is where it's crossing the y intercept, but the 0 is x. So it's 0, -1 for the y intercept right there, right? Because every point on here has has an x and a y. This is the x and this is the y. This is the x and this is the y. So remember how you told me a few minutes ago, you gave me the ordered pair when I had a point. So what's the ordered pair for this point right here? What's the ordered pair for that?
-3 and 0.
Yes. So that's the x-intercept because it's where it crosses the x-axis. So we didn't have to plug it into the equation because we can visually see it. We only have to plug it into the equation when we can't visually see where it's crossing the x-axis. If you can see it, you don't have to solve for it. If you can't see it, then you need to solve for it by plugging in a 0 for the y. Does that make sense? So there's a couple of ways to get it. You can either look at the graph. If you can see it, you can figure out what it is. If you can't, then you have to use the formula. That's how they connect with each other. Does that make sense? Or clear as mud still?
Makes sense, kind of.
Okay. I could solve for it. Would that be better for you than trying to be able to see it on the graph? Do you like the equation better?
How do you know when you do see it?
You look for where the line crosses. This is the x-axis right here. Right there. That horizontal line right here is the x-axis. Like that. Okay? So wherever it's crossing the x-axis,
I understand.
okay. It's where it is, that's the x-intercept. Basically, it's the intersection. That's where the word intercept comes from. It's intersecting the x-axis at that point. Great clarification questions, though. Now, not to confuse anybody, but I do want to kind of point out where I was going earlier when I brought, this is the equation from the other concept map, okay? This is the one we did just a few minutes ago together. And it's y equals 3x plus 2. And we've already made a wonderful connection that these are perpendicular to each other because their slopes are opposite reciprocals. Opposite reciprocals, all right? So I'm going to quickly graph this equation from the one that we did previously, and I'm going to do it on here as well. You do not have to do this. I just want to make a point. This is just me trying to show you how opposite reciprocals, all that stuff works, okay? So I've plotted my y-intercept where it crosses the y-axis, and now I'm going to use my slope to connect some additional points. My rise over 1 is 3 over 1, so I'm going to go up 3, 1, 2, 3, right 1, and then down 3, 1, 2, 3, and left 1. These are perpendicular lines, and where they intersect right here makes a right angle on all 4 sides. It's a cross, turned sideways, kind of, an X. But that's what perpendicular lines do, is they form a right angle. Their slopes are opposite reciprocals of each other. And I purposefully chose lines, and I would love to see you guys figure out what they are, where they are going to be perpendicular to each other on these concept maps, except for this other page, okay? This y equals negative 4x and this x equals 1. They are not perpendicular and they're not associated. My preference would have been if this would have been a vertical line, but it wasn't. My vertical line is up here, and I don't think I gave that to you guys. I probably need to fix that for next year. This is the paper I gave you guys, right? Y equals negative 4x. Is that correct? And x equals negative 1. Is that correct?
Yes, ma'am.
I think it's page 2. Okay. I'm going to go back here to make sure. Does this help you guys with perpendicular lines before I move on to one of the other concept maps? Does this help you a little bit to understand what they are and how you connect them to the graph? Yes?
Yeah.
No? Yeah. Okay, good. All right, I'm going to move down to y equals negative 4x. What is the y-intercept on this one? Can we even tell?
It's 0.
It is 0 because, good job, because nothing is written there, it's a 0. And the x is always what at the y-intercept? It's always 0 at the y-intercept. So lo and behold, because it looks like it's going through the origin. Oh, that looks like a smiley face, sort of, or a nose. And this, we automatically know the x-intercept with this one because the y-intercept and the x-intercept are pretty much the same because this line goes through the origin. Whenever you don't have a y-intercept and you just have y equals something, you know that line, it's a form of an identity. You know that line is going to go through the origin, which is 0, 0. All right. What is the slope on this line? Can we tell?
Negative 4.
It is negative 4. Good job. And I'm just going to write down here that it's a ratio just so we can remember it's the change in y over the change in x. Okay. And we know one of our points. Now we're going to use our slope to graph a few more. It's a negative slope. So I have to travel in one positive direction and one negative direction. So I'm going to start with going down. So that's negative. 1, 2, 3, 4. Okay. And then since I went down 4, I've got to travel in a positive direction. So I'm going to go right 1. All right. And now I'm going to travel in a positive direction. 1, 2, 3, 4. And I'm going to go left 1 because that's a negative direction. So this is a very steep line because negative 4 is a pretty steep, a nice line, Miss Sparks. Okay. So what is the ordered pair for this point? Right here at the top where the green check mark is. What is that point? Negative 1, 4. Good job. Negative 1, 4. And for this point?
1, negative 4.
1, negative 4. Good job. We're really overachieving in our 2 points on the graph area, so good for us. Now, y equals negative 4x. To move it to standard form, I'm going to add 4x to both sides. And now I have 4x, plus y equals 0. Okay. X equals negative 1. This is a vertical line because all lines, equations of lines that begin with X are vertical. So it is never, ever going to cross the y-axis because it's a vertical line. So there is none. Because when I graph this, it's just going to be a vertical line. It will never, ever, ever, ever touch the y-axis. It actually runs parallel to the y-axis. And actually, the y-axis has an equation of x equals 0. And it's a parallel line to that. What is the slope of a vertical line?
Undefined.
Good job.
Undefined.
Slope. Yes, good job. You guys know this stuff. The slope is undefined. Okay? The standard form of this equation is just that. It's exactly what it is. You cannot change that in any way. It's just, it stays the same.
I have a question.
2 points. Yes, love.
Sorry. Why would it be plotted on the 1 instead of negative 1?
Oh, I'm so sorry because Miss Sparks graphed it wrong. Bless you, my love. Good catch. Good catch. Thank you, sweetheart. Okay. 2 points on the graph. We already know our x-intercept, and we can pick any of these, any one of these points. So what's another point on this graph? We know that the x is going to be this.
Negative
Give me
1,
another
negative,
point.
Negative 1, negative.
Negative 1 what?
Negative 4. Negative 4.
Good job. Negative 1 what?
Negative 1, negative.
I think you
2.
said this, but I'm not. Negative 2? Yes, that is correct. negative 1, 2, negative 1, 3. We can really be overachievers now because we know the x, and literally no matter what the y is, x is always going to be negative 1. Doesn't make any difference. You could pick any number in the whole wide world and make that the y coordinate, but the x will be negative 1. A parallel line to this is the y-axis is x equals 2, x equals 4. Those would all be a perpendicular line to a vertical line is a horizontal line. And a horizontal line has an equation that begins with y. Y equals something. Okay. Did this help you guys? Is this helping you connect the graph and the equation a little bit?
Yes,
Yes.
ma'am.
Oh, praise the Lord. Are there any questions over this lovely worksheet?
Can you do 15?
I'm sorry?
Number 15.
15? Yes, ma'am, I can. Write the standard form of the equation of the line. I'm gonna mark this out so that y'all don't think I'm doing that one. I start with the equation y plus 1 equals 3 over. Am I doing the right one? Is this the one you asked for, baby?
Yes, ma'am.
Okay, y plus 1 equals 3. I'm going to distribute that 3 halves. Throughout the parenthesis. And now I'm going to subtract 1 from both sides. My side work, 9 halves minus, I'm going to convert that to 2 over 2 because 1 expressed with 2 as the denominator is 2 over 2. So negative 9 minus 2 is negative 11 over 2. Are y'all tracking with me so far? So that actually becomes, oh, we're good. Never mind. Miss Sparks wrote it. Negative twice. What's she doing? Okay, so now I've got 3 halves x minus 11 halves. That's where I am so far. What form is this? Anybody tell me? What form am I in right now? I need to go to standard, but where am I right now?
Slope intercept.
Slope intercept. Good job. Okay, so what I want to do to get it into standard is I have to move this 3 halves x over to the other side. So I'm going to subtract it from both sides. Miss Sparks writes so big. So that gives me negative 3 halves x plus y equals negative 11 over 2. So I don't want that negative and I don't want that fraction, right? So what I'm going to do is multiply this whole thing by a negative 2 because that's going to get rid of my fraction in the front and it's going to get rid of my negative. So multiply the whole thing by negative 2. And negative 2 times negative 3 over 2 is going to give me a negative 3. Or no, I'm so sorry. It's going to give me a positive 3 x. And a negative 2 times a positive 1y is going to give me a negative 2y. And a negative 2 times a negative 11 over 2 is going to give me a positive 11. So it's B. Good question. Y'all are working really hard at this. I only needed you to get through 12, maybe 14 today. That's amazing. I appreciate how hard y'all are working. This is going to help you guys so much for the final and also for geometry next year. Hang on to all this information about linear equations. I'm sorry, love. I interrupted you. What, baby?
Worksheets tomorrow in class.
Are we getting what?
More worksheets.
Worksheets? Yes, ma'am. There's one that you'll make a ladder with, and I think there's like 8 to 10 problems on it. And there's a Google activity that's posted. I'm going to show you guys how to do it. It's kind of fun. You just basically cut and paste your answers. Let's see. Oh, and we're going to do a maze activity. Where we get our stations activities, where it's a scavenger hunt where the one answer leads you to the next answer.
Okay, cool.
So, yeah. So that's why I wanted to kind of briefly introduce you guys to the parallel perpendicular line thing again, so that you'll be prepared. But tomorrow we're going to be moving around the room a little bit. And please, please, please help each other out. Teach each other and help one another. Really get this, because what I'm seeing, it's really fun. I love how the Lord works, and the fact that a lot of you are making certain connections in certain areas, and some of you are making connections in other areas, and you each have different strengths. So y'all are looking like the body of Christ. So I want you guys to operate like that tomorrow, in class. It's really sweet. So definitely help each other out. Because, I have a tendency to speak in math speak, and you guys teach in student speak. And sometimes you can explain things in such a more, like a way that's a little more profound to your, brothers and sisters in Christ than I can, because I kind of stay in math speak. So I love to see you guys lift each other up and build each other up and help each other. So please know that, we're gonna do that tomorrow in class, and we'll work some more Thursday. Thursday will be a day that we'll just, like in math lab, we'll just continue to go over some of these same worksheets and concepts. Come to class with questions, but come to class ready to work, because I really want to see y'all succeed on the final. And about 50% of the final or better is going to be on this stuff right here, because this really incorporates everything that you've learned this year. Because if you'll look back on what we've learned, and it's going to be fun going through the reviews, because you'll be like, wow, I remember when we were learning this and thinking this is hard, but y'all have become so successful at things. And it's going to be great to be able to visualize your growth. And I want to do that during the review. But this incorporates everything that we've learned this year, manipulating equations and solving for either X or Y. That kind of translates into those literal equations that y'all hated so much. And now you're doing it. You're actually putting it into play and into practice. So this will be a good bit of your final. So that's why I wanted to really make sure that you had this nailed down. Are there any other questions on the 3 worksheets that were handed out yesterday in class, or anything in general that I could answer for you guys this morning?
Miss Sparks, I have one more question.
Yes, ma'am.
On number 7. How do
On this worksheet that we're on, baby?
Oh, no. For the graph.
This one?
Yeah, number 7.
Yes, ma'am.
How do you find the slope? In the x-intercept?
Okay. Just kind of like number 5. It's a horizontal line, right? So what's the slope of a horizontal line? All horizontal lines have the same slope.
Oh, 0.
Every single one of them. Yes, every single horizontal line has the exact same slope. And the y-intercept, 1, 2, 3, 4, 5, 6, 7, is 0, -7. And this horizontal line will never, ever, 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 ever cross the x-axis. So it has no x-intercept. It runs parallel to the x-axis, just like a vertical line runs parallel to the y-axis.
So how would you write that all as one?
All horizontal lines have an equation that begins with y and identifies the y-intercept only. Because if you think about it, if the slope were 0, even if I wanted to solve for something, if the slope were 0, I could put anything I wanted to in for x, couldn't I? Because all of these have x coordinates. But I could put anything in. A 1, a 2, a 3, a 4, a 100, 1,000. I'm still going to get y equals -7, right?
Yeah.
Because that's my slope. Yeah. Right? That's how all that, it's still, even though we don't have to figure all this out algebraically, it still works algebraically. It's still true. Good, beautiful thing about math is it's still true. It still works out. Just like God. He's always truth.
And also on number 2, I don't know how to write.
Number 2,
Yeah.
you don't know how to do what?
Oh, wait.
You didn't know how to do what with it, honey?
Never mind. I was
Okay.
overcomplicating it.
Okay. I think
number
that happens to a lot.
For number 8,
For number 8, let me work it out. Let's see. 1, 2. Did you say -2/1? Or 2/1 negative? Is that what you said?
-2/1, yes, ma'am.
Yes, it sure is. Way to go.
Oh,
In that one, you're going to have to graph, or have to solve algebraically to get that y intercept. Because it goes through it a slightly off spot. So you'll just substitute 0 in for y and solve for x. Okay, any other questions?
On number 6, once you find the slope, y-intercept, the slope is 1. So how do you write y? Mx.
X what the slope is 1, right? What's
Yeah.
the y-intercept?
Yeah.
3.
And the x-intercept is 1. I'm sorry, 3.
That's 1. I'm sorry, 3.
Because remember, there's the answer. Because remember, 1, the coefficient 1 can be written, but it doesn't have to be written because it's understood. Right?
What happened to the x-intercept?
X-intercept.
It's not displayed in the slope-intercept form. It doesn't show up there, but I could solve for it if I put a 0 in for the y. I can solve for it, right?
Oh, okay.
Yeah, it's not in the actual equation itself. It's all this whole thing is a little like the mapping in that I'm trying to get you all to make connections, making connections between the graph and the line itself and the various points on the line. Okay, that's the whole point of these exercises. There's a graph and there's a line. There's typically an x-intercept, typically a y-intercept, except for when there's horizontal and vertical lines, as we're seeing. And I'm just trying to make you all get connections between the line and the graph. But it doesn't always mean that, like, the x-intercept does not show up in the slope-intercept form. The slope-intercept form references the b, which is the y. Okay?
Okay.
All right.
That's the answer for number 8.
Say what now?
Is that the answer for number 8 in the box?
It's the answer, as far as the formula is concerned.
Yes, ma'am.
Oh, wait. You know what? We went up 3 on that, Eli. Not 2. It's 3. I'm glad we caught that. Do you see that? It's so hard right here to count that. So 1, 2, 3. Those were really close to each other. So it's actually -3 over 1. My apologies. Oh, and I think, did I check? Yes. When you said it was 2, I think I was looking for it to be 2, but that is so close. This little line right here, that coordinate, 1, 2, 3. So we go up 3, left 1, down 1, 2, 3, right 1. I'm sorry about that. So it's -3x minus 4. G. Has anybody found the x-intercept for number 8 algebraically?
No, ma'am.
No, ma'am.
Okay. All right. I'm gonna leave that to you guys though. Just substitute a 0 in for the y, because I want to make sure you guys know how to do it. And you can show me tomorrow. You can tell Miss Sparks can't count sometimes too. So it just happens. Got to take our time, that's for sure, so we don't make the simple mistakes. It's common to me as well.
Oh, I think I might have gotten it.
Okay, what'd you get, baby girl?
Is it 4 over negative 3?
It is 4 over negative 3. Good job. Maybe tomorrow in class, you can demonstrate that. Are you and Eli in the same class?
Yes,
I
ma'am.
can't remember.
Yes, ma'am.
Okay. Maybe for your class tomorrow, we'll have you do that one on the board.
Okay.
All right. Any other specific questions? We got a lot of this done. We got 1, 2, 3, 4 of the 6 concept maps too.
Oh, on the your review sheet where it says the equation and the slope and 2 points on the graph.
What number?
The second one. Oh, not on that sheet. The other one that you handed out yesterday.
Yes.
Yeah.
Yes.
I could find the slope and the y-intercept, but I couldn't find the x-intercept.
What do you have to do the x-intercept? Were you here earlier in math lab, or did you get here late?
I got here late.
Oh, buddy. It will definitely help you if you have an opportunity to watch the first part of this. It will definitely help you. But what you do to find the x-intercept, since you got here late, I definitely want to cover this with you. But okay, you got the y-intercept, and you got the slope. So you know you've got one of these. With the x-intercept, you know that the y is going to be what?
-2.
No, the y coordinate for the x-intercept.
Oh, 0.
So you would plug 0 into the equation and solve for x.
So then would you put it in like y equals mx plus b?
It's in mx, y equals mx. Oh, yeah. Oh, what do you mean? Is that the equation I used to find it?
No, the standard.
Yes. I used that. Because I already have this, I'm using that. Any one of these forms will work with one of the ordered pairs, any one of them. So if you have one, use the one you're given. Any one of these, any form that you have of the equation will work if you substitute coordinates into it. I don't know if you remember, but way back when, we might be given an ordered pair and we would say, check and see if the following ordered pair, actually, let me do this one so it would be really specific to this line. We had questions on homework that said, check and see if the following ordered pair is a point on the line or if it works for that equation. And what that means is I should be able to plug in this ordered pair, that 1, -4, into this equation, the 1 for the x and the -4 for the y. And if I solve it, it should make a true statement.
Okay.
Okay.
So how would you write that in the standard form of the equation?
Okay, how you tell me.
Would you start out with y equals?
Yes. Now what do I do?
-2x.
What do I do to it? How do I do? Can I just move it to the other side? If I want to, I can just, oh, let me just stick it on the other side.
Oh, you have to add it.
Can I do? Right. So I'm going to add 2x to the other side. And I have 2x plus y equals -2. And now it's in standard form.
Okay.
But if you did get here late, I covered a lot in this math lab. And if you have a chance to go back through it, it would be well worth it, baby girl.
Okay, I'll do that.
Okay. I'm sorry, you know, I know it's sometimes life gets crazy, doesn't it?
Mm-hmm.
And if you need to, just you're like, oh, I don't need that part. The good part about going back and rewatching is you can kind of speed it up through parts you don't need. You know what I'm saying?
Yeah.
So even though math lab is long today, you might not need it all, baby girl. And a lot of times that first 4 or 5 minutes is just me trying to get it all set up because I have to actually start the broadcast before anybody gets here. So you can definitely usually skip the first 2 to 3 minutes for sure. So it won't be a complete waste of your time because I know y'all have a lot of things to do.
Okay, thank you.
You're welcome, baby. And just so I'll go ahead and post this video because I'm sure you're not alone, love. All right. You have a very blessed day.
You too. Thank you.
Uh-huh. Any other questions? Eli, do you have anything, honey?
No, ma'am. Thank you.
You're most welcome. Have a blessed day.
You too.